Let's start working through these homework problems here. So for the first one, we're told a water bottle left in the woods can start a forest fire. So we want to explain how this could happen. So what I would be thinking about here is a water bottle is shaped a little bit like a convex lens. And so when light rays come in and hit that water bottle, like from the sun, what's going to happen is it's going to bring those light rays together at a point. That point can get fairly hot because you're concentrating all of that light. It's very similar to what people might have done with a magnifying glass and a mound of ants when they were younger. But the basic idea is you're concentrating all that light, all that energy onto one spot, and that potentially could start a fire. For this next one, we want to determine whether or not the images described here are real or virtual. So we're thinking about all the concepts we know about those two types of images. So a movie projected onto a screen, only real images can be projected onto a screen, so that first one must be real. The image of a person when looking at a normal mirror, what we're going to remember with this one is when you're looking at yourself in a mirror, that image is upright. Upright images must be virtual, so that second one's going to be virtual there. A person using a magnifying glass to read the fine print at the bottom of a paper, same idea as this previous one, that also is going to be an upright image. If you're looking at something that's close to the magnifying glass, it doesn't flip it upside down. It does when it's far away, but up close it doesn't. Therefore, it's a virtual image because it's still upright. And then we look at the opposite situation using a magnifying glass to look at something far away when it appears to be upside down. Since that image is inverted, we know that inverted images must be real. So for these problems, we're going to go ahead and draw some ray diagrams, and then we're going to use those ray diagrams to determine the location of the image, ultimately measuring DI and HI, and then filling in our image characteristics. So let's go ahead and start setting this one up like we've done with some other problems here. So we have a converging lens. You can go ahead and draw the lens. I'm not going to do that at this point. You guys know what that looks like now. With a focal length of 10 centimeters, that we will fill in. So I'm going to put F right here. There's my focus, and then F prime, of course, will be the same distance but on the opposite side. A person's going to stand 30 centimeters away, so they're going to be standing right here. And we want to set the scale for the y-axis. So what I'm going to say is each one of these is going to be 0.5 meters. So 0.5, 1, and then 1.5. So we're going to have our object be 3 blocks tall. We usually do 2, but 3 works just as well. We're going to go ahead and keep in mind what our 3 rays are. So we'll start with that first parallel ray. So this first one's going to go in parallel. Here's the center of the lens, even though I didn't draw the lens itself. Once it hits there, it's going to go out through the focus. The second ray is going to go in through F prime. Once it hits the lens, it bends and goes parallel. And the third ray is going to go straight through the middle. So we can go ahead then and locate our image. All the rays converge at this point, and so our image would look like this. So we can now go ahead and fill in HI and H and DI. So we see that DI is going to be right about here in between 15 and 20. So I'm going to call that 17.5 centimeters, which may vary some from the actual answer. Part of it is about how exactly you do your drawing, but that's okay if you have an answer that's slightly different than the one that's listed down there. We're also going to go ahead and determine HI. So we were about 1.5 blocks, maybe close to 2 blocks. So I'll go ahead and just call it 2 blocks and say that my HI here is going to be -1 meter because for my scale up here, each block represents 0.5 meters. The final bit we want to do is we want to go ahead and circle the characteristics of this image, and so this is going to be a real image because those light rays actually converge and come together. It is inverted, as we can see, and it is smaller than the object. Moving on to the next problem here, we're looking now at a diverging lens with a focal length of 40 centimeters. So we keep in mind that with that diverging, F is going to be over here on the left-hand side, and F prime is going to be over here on the right-hand side. Again, I always do this assuming that The light is going from left to right. We can go ahead and set up our object here. So our object is 25 centimeters away. So it's going to be right in here, and it's 10 centimeters tall. So I'm going to say that each block is 5 centimeters. That means that 10 centimeters tall will be 2 blocks high and located right here. We're going to go ahead then and do our 3 rays. So we start with our parallel ray. We go in parallel, hit the lens, go out through the focus, but keep in mind the focus is back here, so we're going to go out along that line with the focus. For the second one, we're going to go in through F prime, which is over here, so we're going to be headed towards that F prime, but once we hit, we're going to bend and go parallel, and then the third ray still goes directly through the middle. So we'll go ahead and trace back all 3 of those rays, and we're going to find that they converge right here. And so we can go ahead and draw our image. We're now going to use that image to estimate HI and DI, so it appears right about here. So my DI, I'm going to say, it's about 15 centimeters, but because it's virtual, I'm going to make it be a negative 15 centimeters. And then the height of it, if I look, this is the 5 centimeter mark. It's a little bit taller than that, so we'll maybe call it just 6 centimeters here, something a little bit over 5. Certainly not quite 10, so anywhere from say 6 to 7.5, somewhere in that range is probably a pretty good estimate. It is a virtual image here because we had to trace back those rays. Obviously it's upright and it is smaller than the object. All right, for this next one, we have a student examining a cow eyeball using a converging lens. If you think this is kind of a weird problem, we did actually used to do cow eyeball dissections, and that's the reason for this problem. We obviously don't anymore, but I don't just pick random things. So anyway, the cow eyeball is in front of this converging lens with a focal length is 10 centimeters, so there is F. F prime is going to be this point over here. The cow eyeball is 3.5 centimeters tall and 6 centimeters away. So it's going to be located right about here. And I'm going to say each one of these blocks is 2 centimeters. And so the cow eyeball is going to be about to that point right there, short of 4 centimeters, but more than half the way between 2 and 4. We're going to go ahead and draw our 3 rays. So our first one goes in parallel and out to the focus. Second one, it's going to go in through F prime. So what we're going to do, remember, is we're going to start with F prime, go up through the top of the object, and then go parallel from there. And our third one just goes directly through the center. As you can see, they're not going to converge over here. They're spreading out. So what we're going to have to do is trace each of those rays backwards. So we'll go ahead and trace them backwards, and we do find that they converge here at this point. And so we can draw our image based off of that. So we'll go ahead and find DI and HI. So we see it appears right about here. So that looks like this is 15 centimeters, that's 20. I'm going to call that about 16 centimeters. And because it is virtual, I'm going to make that DI be negative. Okay. And then the height of it, we see that each one of these is 2. So 2, 4, 6, 8. A little bit more than 8. We'll say it's about 9 centimeters tall. Again, some of this is an approximation, so if your numbers aren't exact, that certainly is okay. All right. In terms of the characteristics, it is virtual because we had to trace it back. It is upright, and it is most definitely bigger than our object. All right, let's go ahead and work through this final problem here. So we have another converging lens, so let's go ahead and set that up. The focal length is going to be here at 10 centimeters. F prime is going to be at 10 on the other side. And we're going to go ahead and draw our object, which we know is also at 10 centimeters. Now, we're not given a height here, so at first you might be thinking, how are we going to do this problem? I'm just going to draw it 2 bars high, but this really is a special case, as we'll see in a second. So you can either remember your concepts, or you can go ahead and start to draw your rays. We can draw our first ray in parallel out through the focus. We're not going to be able to draw this second ray here because that would require us to go straight down through F prime, and that's not really possible. But we can draw our third ray straight through the middle, which just goes down like that. And what we see is these 2 rays are parallel. And so we have a situation here where the focal length is 10, and we're putting our object also at 10. So whenever we place the object at the focal length, that is a special case for a converging lens, and it results in no image. So that is our answer for this one.